Hello, welcome to the ALCTS webinar, Linked Data Description of Cartographic Materials. I'm Matt Montgomery from the College of San Mateo. I'm a member of the ALCTS Continuing Education Committee, and I'll be your host for today's webinar. Our presenter today is Marc McGee. Marc is the Geospatial Metadata Librarian at Harvard Library. He is the coordinator for the Linked Data for Production Cartographic Materials project. Marc has over 13 years of experience cataloging geospatial resources, including rare paper cartographic materials in the Harvard Map Collection and digital geospatial data sets for the Harvard Geospatial Library. There are a few things to keep in mind for today's presentation. All attendees are muted. If you have questions for Marc, please type them in the question box on your screen, and he will answer them at the end of the presentation. Our software does not have interactive chat capabilities. You may use the ALCTS hashtag if you wish to use Twitter to comment on today's webinar. The hashtag is ALCTSCE. We do not monitor the Twitter feed, so please use the question box to submit questions and comments. This webinar is being recorded and you will receive an email with links to the recording and the presentation slides. And now here's Marc. There'll be a slight delay as we change presenters.
Okay, thank you, Matt. Thanks for the introduction, and thank you, ALCTS, for hosting this webinar. Good afternoon and good morning to everyone attending, whatever the case may be. Before we get started, I wanted to take a moment to tell you a little bit more about myself. My first foray into map cataloging was as a project cataloger for the Harvard Map Collection, and I consider myself very fortunate to have had the opportunity to catalog Harvard's collection of antiquarian maps of New England as one of the early map scanning projects for the university. And in 2005, I jumped forward a couple of centuries in data technology and started in my current role as the Geospatial Metadata Librarian for Harvard. Those responsibilities include creating XML-based metadata for digital geospatial data sets collected in the Harvard Geospatial Library. And in that time, I've learned much from my colleagues, particularly the ALCTS, CAMS, McGee Cartographic Resources Cataloging Interest Group of ALA. It's a really great community for exchanging information about cartographic resources cataloging. If you're going to be at ALA, I would suggest and recommend that you think about attending the Cartographic Resources Cataloging Interest Group. I learned a lot from that community, and some of these ideas that I'll be presenting today emanate from conversations had in those types of meetings. So I'm happy to be presenting today to another ALCTS audience. Today, I'll be speaking to you as the coordinator of the Linked Data for Libraries Production Cartographic Materials project, which I'll be going into more detail momentarily. And of course, I couldn't resist the opportunity to include this photo and then try to calculate the scale of the map behind me. 1 mark equals approximately 3,200 miles here. This photo was taken in the American Museum of Natural History, and I'm looking forward to making a return visit sometime soon to see if my 1 to 3 million estimate is close to accurate. Those of you in the audience who are adept at scale conversions should also be able to reverse engineer this data and figure out how tall I am. So I'll leave that to you as a challenge. Today, I'm happy to be able to share with you some of the work of the Linked Data for Libraries Cartographic Materials project, including its background, goals, outcomes, and future work. We'll also take a closer look at one of the outcomes of the project, the Geospatial and Cartographic Resources Ontology, which is an attempt to extend BIBFRAME and Biblioteco to enhance the description of geospatial and cartographic resources. BibFrame and Biblioteco are both fairly comprehensive linked open data models used for the description of bibliographic data, especially for standard issue types of materials. And while it'd be interesting to discuss how these two ontologies can be used to describe cartographic resources to completion, the focus of my talk today will really be on the cartographic aspects of description and the modeling decisions that the LD4P Cartographic Materials Working Group considered for this project that go beyond these what these two models really have to offer. So the focus will be kind of more on the cartographic elements. A little bit of background for the broader context of the Cartographic Materials project. The Linked Data for Production Cartographic Materials project is part of a larger Andrew W. Mellon Foundation funded project, the Linked Data for Production project, or LD4P. LD4P has 6 partner institutions seen here. And at a high level, together, we are attempting to develop standards, guidelines, and infrastructure to communally produce native linked open data descriptions. We're also collectively developing end-to-end workflows to create linked data in a technical services production environment. We're also in various ways extending the BIBFRAME ontology to describe library resources in specialized domains and formats. And then one of our goals as well is to engage with the broader library community to ensure that there's a sustainable and extensible environment going forward for making these sorts of decisions. Some of these extension projects mentioned in this third point here, you may have already encountered as part of the ALCTS webinar series from Marc to BIBFRAME, of which this is one. The specialized domain projects also include the Columbia Art Objects domain project. Cornell is exploring the rare materials domain. The Library of Congress is also involved in actually exploring all types of materials. Princeton is working on a project around annotations in their Jacques Derrida book collection. Stanford is investigating technical services workflows as well as the performed music domain. And here at Harvard, we're looking at 2 domains, the cartographic materials domain, and although not technically part of the LD4P grant, we're also looking at film and moving images. The linked data for libraries, production cartographic materials, what we're calling LD4P CM for short. The high-level purpose is really just to explore best practices for creating native linked data descriptions for library cartographic resources, including all types of cartographic materials, printed maps, atlases, born digital geospatial data sets, and other cartographic information resources. And really the intention is it was really to give us a chance to rethink our approach to cataloging of cartographic resources in a linked data environment. So by using open linked data models for cataloging, what new types of questions can we ask the catalog that we can't ask now? With the possibilities of linked data, what changes about the way that we interact with our resources when we're actually cataloging the materials? So I would call this project experimental, in some ways incomplete, and not necessarily prescriptive, but as kind of a chance to experiment and see what types of things we can come up with. And more specifically, the objectives for this project. The project officially launched in March of 2016 as a 2-year project. And we did receive a 3-month extension to finish the work that we had started for the grant. So technically the grant will now end June 30th, 2018. As set out in the objectives of the grant, we really wanted to cover these bases where we wanted to identify use cases that would help guide the work that we're doing. So what do cartographic resource users want and need from library data? And what effect does that have on how we structure the description of that data? What is it that we're aiming for when we set out to describe these resources? Another objective was to evaluate the existing ontologies for suitability for describing the for cartographic resources. How complete are the existing ontologies? Where are there gaps in description? And what can we do about those gaps in description? We also wanted to evaluate existing linked open data vocabularies. So what opportunities are opened up to our library data when we consider other data sources? So for example, GeoNames is a online linked data gazetteer. What advantage are there any advantages to linking to that as a data source, where GeoNames provides some data points that we haven't necessarily seen in our library data, such as population, administrative hierarchies, feature types, these sorts of things? How does that change what we can ask of our data? And then from all these questions, we wanted to develop a BIBFRAME plus cartographic materials linked open data application profile that we could then use to describe these cartographic materials. And from there, we wanted to work to inform the development of a cataloging tool. In Harvard's case, we're looking at a tool called VitroLib, which I'll introduce a bit about. I'll talk about that a little bit more later on. And we kind of wanted to influence the cataloging tools as they're being developed. So that's part of the thinking of this. We, of course, want to do some pilot cataloging work across a variety of types of materials to test the hypotheses and models that we've developed. And we want to document the project, write up recommendations based on our findings and outcomes. And of course, there's no point to this if we're not engaging with the cartographic materials community, the linked open data communities, to help develop best practices together. So those are really the objectives, specific objectives of the project. And to that extent, I knew early on that I would need help. So before the grant project was even approved, I began to recruit a cartographic materials working group, members from library circles that I knew best, the Map and Geospatial Information Roundtable of ALA, McGee, and the Open GeoPortal and GeoBlacklight geospatial metadata communities. So we began meeting in March of 2016. We meet mostly regularly on a bi-weekly basis to tackle some of the objectives of the project. And while our group has a vast experience in some areas, particularly MARC-based cataloging, geospatial metadata creation, only a few of us came into the project with any kind of linked data modeling exposure or experience. And much of what we've done has been a learn as you go process for many of us on the working group. So if you've worked at all in the library, geospatial, and cartographic resources communities, no doubt you recognize some of the names here. I have to personally thank them as well for joining and contributing their time and expertise to the project. The project was ambitious and somewhat daunting in nature, so thank you, working group, if you're listening in. The photo you see here is from a tour that the working group took of the Harvard Map Collection during a 2-day in-person ontology sprint meeting in September of 2016 that many of the working group were able to attend in person. And one of the outcomes of this in-person meeting was to focus the scope of the project. And it included finalizing a set of target use cases and holding initial discussions around ontology modeling needs and priorities to support those use cases. So together, we narrowed down the project use cases to 5 researcher, 3 student, and 3 librarian focused use cases that would help to guide us through our concept modeling work. So here are 2 use case examples that were developed by the group. The first one is a student use case. I am a student studying land development of Shanghai, China, 1900 to the present, and would like to compare a map from each decade at 1 to 50,000 or larger scale. And the librarian use case, as the maps librarian responsible for curating exhibits, I would like to identify, select material from my library's collection of maps that show natural features of South America using hashers as a relief technique. These were devised by the group. We did do some surveying of community users, but some of this was constructed by the group itself. Common concepts that came up across the use cases were, of course, types of cartographic material, feature types on maps, time components, scale, relief, and of course, location, both coordinate-based and place name-based. And some of the use cases also stretched the expectations of what we currently demand of our data and cataloging systems, such as aligning digital file types to software packages that can use those types of data. And there's a link to the rest of the target use cases. It's available at the end of this presentation in the resources links that will follow. It's also available from the project wiki, which there's a link at the end. So after our discussions of use cases, we began to investigate concept areas of ontology modeling and started to discover limitations to the descriptive models that we had reviewed. From this, we began to create a new ontology, the Geospatial and Cartographic Resources Ontology, or GCRO for short, to help support the descriptive areas that we were interested in exploring more in depth than what was provided by existing ones. The Geospatial and Cartographic Resources Ontology is intended to work in combination with other ontologies to support the description of geospatial and cartographic resources. BIBFRAME is the foundational ontology we use as our basis. That's our starting point. And GCRO also relies heavily on Biblioteco, which is a BibFrame extension ontology that was created by the larger LD4P multi-institutional project and takes slightly different approaches to describing resources, some of which I'll describe in a moment. We really did not want to get into the ontology building business. So the goal was really to reuse as much of existing linked open data ontologies where we could. Examples of ontologies being reused include RDA, Geosparkle, Web Annotations Model, DCMI, and Friend of a Friend. In addition to ontology decisions, another aspect of the Cartographic Materials project that we wanted to explore was being able to use and recommend entity vocabulary sources that are perhaps not traditionally used in standard library descriptive data. So are there cataloging efficiency gains or other types of data relationships to be gained by using different entity vocabularies? And an example would be the GeoNames example that I had given earlier. And then from there, we developed an OWL-based ontology for those areas where we identified as they're lacking a sufficient existing ontology. So GCRO is currently available as a beta version. The caveat about the beta version is it has not been rigorously tested yet and may undergo significant changes as we do begin testing. Another caveat is we don't actually have a permanent namespace for it yet. It exists only as an OWL file. And you'll see we're hoping to have a place to host it by the end of June. So, as I mentioned, GCRO is not intended to be a self-contained ontology. It works in conjunction with many other ontologies that together go into describing geospatial and cartographic resources. In many cases, the recommendations of the Cartographic Materials project will be to defer to the modeling decisions already made within the other ontologies. So what you're seeing here is a list of selected descriptive areas and the corresponding model and ontology that this project is intending to use to test the cataloging of cartographic materials. So at the very top, we're intending to use the work instances items model that is presented within BIBFRAME. From there, we intend to use bibliotecal models for activities. The activities model includes things like agents and so publisher agents, author activities, publishing activities. So you typically see your agents embedded within activities. Titles, content carrier media, subjects, and notes and annotations. And then from there, the descriptive areas that are common to cartographic type description, scale, relief, projection, coordinates, types of cartographic resources will be, you'll see in a minute, more detail about how GCRO intends to augment BibFrame and Biblioteco. As well, we intend to use some RDA, parts of RDA, and even using other parts of the LD4P within other parts of the LD4P. The art frame and rare materials group has been working on a measurements model, which we'd like to reuse for cartographic materials as well. So it's also not as simple as it appears here, as many of the models listed here often reuse parts of other models within their own ontologies. So an example of that would be in Biblioteco's recommendations for notes and annotations. It actually blends the web annotations model with some BibFrame properties, as well as with some Biblioteco-defined annotation motivation individuals. And there's even in some parts of GCRO, there's even parts that go into the notes and annotations model. So this combination of selected ontologies shown here is just one of many ways one could attempt to describe these types of resources. This is just the way that we've chosen to approach it for this project. So while the goals of the Cartographic Materials project were lofty and in many ways difficult, in practicality, we had to start with some lower hanging fruit to get more practical modeling experience under our belts before tackling the more complex concepts. So the prioritized modeling areas shown here address at least portions of the use cases that we identified above. And these are common concepts that are encountered every day by map catalogers, and we weren't necessarily these weren't necessarily addressed comprehensively by existing ontologies that we reviewed. So this is these are the areas that we've identified for that needed modeling. And this is where we're going to go a bit into the weeds for a while, I'm going to compare the BibFrame models to the proposed GCRO models. And I'm going to present models of these concepts, as well as some RDF class and property examples with sample data from these areas that will kind of give you an idea of why we ended up deciding to experiment with developing a separate ontology. And you can link to these examples of these modeling areas at the GitHub link below. So starting with cartographic scale, BibFrame does indeed have a class and a property that addresses cartographic scale. And what we're looking at is some BibFrame documentation about the scale property. Here you can see that the scale property can be used with a BibFrame work or instance, and the expected value is a BibFrame scale object. So what this looks like is in terms of the RDF and how BibFrame models scale. This is what it looks like as applied to a specific resource. And I should mention here that the BIBFRAME RDF example data that I'm going to be presenting today was generated from the Library of Congress Marc to BIBFRAME comparison viewer, which is an online tool that allows you to pull up Marc records from the LC catalog and do a Marc to BIBFRAME conversion on the fly in order to do side-by-side comparisons of the Marc and BIBFRAME data. So a link is provided in the resources section at the end of this presentation if you want to do some comparisons yourself. But here, looking at this specific example of how BIBFRAME might model some what we're used to seeing Marc data. So looking at the Marc data here, we're used to seeing the machine readable scale data in the 034 subfield B and the human readable version of the scale in the 255 subfield A. Looking at the BIBFRAME RDF example here, the LC converter takes these two areas of Marc data and turns them into two separate BIBFRAME objects. So the first scale object, which it starts with the first open bracket on the left there, has a label consisting of the 034 scale denominator value, and then asserts a related note, a note object, identifying that it is linear horizontal scale. The second scale object, which starts with the opening bracket on the second to last line here, takes the human readable 255 data and puts it in a label literal. So it's text there. In the Marc and BIBFRAME models, these two scale assertions are not directly related, even though we as humans know that they're different ways of expressing the same data from this map. We also know as map catalogers that there is some semantic nuance to the way in which we encode the scale data in a Marc record. So for instance, brackets around the representative fraction in the 255A means that the scale is calculated in some way. A lack of brackets would mean that the scale is provided as a representative fraction. And we know this only by the punctuation present and not by any explicit assertion in the data. So in comparison, this is what we're proposing for the GCRO model for scale. This is a graphic showing kind of a general, what the general model would be. Here we have a work resource on the left that has the property BF scale, so we're using the BIBFRAME property BF scale, that is associated with a BF scale object, same as BIBFRAME. However, you'll notice here that under the BF scale object, we've added some subclasses of scale types. So here we have horizontal scale, vertical scale, scale not determined, not drawn scale, etc. We've turned essentially, some of these would be encoded in Marc as a fixed field. Some are textual in nature, but in this way we can be more explicit about what type of scale we're talking about. We've also added a GCRO, we've added a property called scale accuracy, which you can assert directly to the scale object. So you can say now within this model that this scale has an explicit scale, an approximate scale, and an inaccurate scale, or the scale accuracy is unknown. Additionally, we added we decided to add another property around the source of the scale. So the GCRO scale source, you're able to assert whether you've determined the scale by using the representative fraction, using a verbal statement, using a scale bar, or if it was calculated from the primary source in some other way. So in this way, it kind of takes out some of the interpretation that is left, that is a vestige of punctuation, and turn these into objects. Additionally, there's a direct way to assert the representative fraction denominator and to type the data type as an integer, so we know that this will be a machine actionable data point. And we're reusing the RDA unconstrained property for has additional scale statement to still allow for textual description of a scale. So this is what it would look like. Is what it would look like in RDF, in the GCRO RDF. So compared to the BIBFRAME converted example, we have one scale object here instead of two. So the work has one scale object that is asserted as a horizontal scale. It's more succinct and descriptive. It turns strings into things. So the type of scale, scale source, and scale accuracy are all now linking to things. And the representative fraction denominator you'll see here is it's typed as an integer, so we know it's machine actionable. And the RDAU property here, you're still able to assert a human readable portion of the scale statement. And it's just a cleaner way to model. It seems to be a cleaner way to model something like scale. And you can find more scale examples in this document below. We've kind of tried to approach presenting different manifestations of scale and how it would look in the GCRO model. So another concept area that we looked at was cartographic relief. BIBFRAME does not, in fact, provide any specific properties, classes for relief. And here we have an example Marc record with relief coding in the 008 for contours and spot heights. We also have a relief note in the form of a 500 note. And then there's some extra data about the contour intervals in another 500 note. And on the left, you'll see the BIBFRAME converter has turned the 034 relief codes into two separate cartographic objects that have a BF note where the label is relief type, and the note type is coded as relief. So this is fine. It would probably work for machine purposes, though we're still dealing with some strings as literals. On the right, you'll see that the BIBFRAME converter has converted the 500 data into two BF note objects, one for the relief 500 and another for the contour intervals note. The 500 data is in no way related to the 008 data, which is not necessarily a failing of the converter because it's similarly structured that way in Marc. However, let's look at how this might alternatively be modeled. So here's the GCRO relief model. We have decided to use the RDA unconstrained property has relief type to associate a relief class with either a worker instance. And this is a new, I should say, this is a forthcoming RDAU property. I don't think it's officially been published yet, but we were very glad to hear that RDA had introduced this into the vocabulary. So in the GCRO ontology here, we've created a relief class, and then from the Marc relief codes that we're used to, we've created hierarchical subclasses of land relief, water relief, no relief, etc., with specific types of the relief subclass even further. So underneath the land relief, we have things like contours, form lines, hashers, etc. And this adds some new functionality to the model that is not currently available, the way that Marc is currently encoded. And there isn't a simple way, right now there isn't a simple way to ask our catalogs, well, what maps do we have that show land relief of any type? This sort of modeling can answer that. As well, it turns some more strings into things. In addition, we have a way to add a note about any specific relief object through the RDFS comment property here. And if we want to look at this in RDF example, so the GCRO relief example, There are 2 relief objects, one for contours, one for spot relief, and the contour interval note is now associated with the relief type that it applies to. It's not shown here, but both of these relief types would inherit the land relief superclass through the ontology, and because there is now a semantic relationship asserted through the GCRO ontology, this allows for an additional path of discovery. Our group did indeed think about taking this one step further and modeling for the contour interval values and units. However, we stopped short of doing this for this project, but one could certainly make the case for extending the modeling in this way so that one could search for more examples, say for maps with contour intervals of 20 feet or less. And again, there's more relief examples available from the bottom of the screen. The next concept area that I wanted to talk about is cartographic coordinates. So obviously, spatial-based search is something that we want to enable, and BIBFRAME has a property for coordinates, but not a coordinate class. We can see here that the BIBFRAME coordinates properties expects the coordinate values to be a literal. Looking at the Marc to BIBFRAME conversion on an example Marc, some example Marc data. Here we have the 034 machine readable data and the 255 subfield C human readable encodings for bounding box coordinates. And similar to the relief example, the BIBFRAME converter puts the 034 and 255 data into separate cartographic objects and then converts the content as a string literal. This is fine, but it's somewhat simplistic, and there's no real improvement from our current Marc encoding. So we're going to take a look at what we're proposing with GCRO. So the GCRO model proposes to use the RDAU property, has coordinates of cartographic content, to make the relationship between work resource and GeoSparkle geogeometry object. So the geogeometry class is it's an open geospatial consortium web standard that has the advantage of being able to represent multiple types of geometries. In this case, we are also using the GeoSparkle format for describing the coordinates. Geo as WKT, that property is known as WKT stands for well-known text. It's a literal, but what the Geo WKT literal is it's a standard encoding format for representing different types of coordinate geometries. In addition, the GCRO model also proposes to make an assertion as to the source of the coordinates that the geometry is coming from. So using the biblioteco property bib has source, the name individuals under the GCRO source are coming from a Marc list of cartographic data source codes. So it includes sources like the Cloaken bounding box tool, which is a useful tool for deriving coordinates for maps that don't have the data on the map itself. Looking at this as an RDF example, we have a work. You can see that the work has a geometry object that contains the bounding box source. It's related by the biblioteco property has source, and the GCRO object for the Cloaken bounding box tool, which is that GCRO bound. The bounding box coordinates are represented as well-known text polygon string. It consists of 5 coordinate pairs. The first and last pair are the same, signifying the opening and closing coordinate pair of a bounding box. In the GCRO model, we have also accounted for the possibility that the work itself could be the source of the coordinates. So here in the curly brackets, you can see the text in italics there that the bib has source assertion is actually linking back, it's referencing the work itself. You'll also notice in the example that the coordinate data is in decimal degrees. There are good reasons for degree, minute, second notation that we've used for recording in Marc. However, I think for encoding purposes, our systems need to get with the times and convert this data into decimal degrees for easier and more standard machine manipulation. I think our cataloging tools can support either coding method on the input side, but when it goes to save our records, it would be easy enough to convert on the fly into standard decimal degrees notation. So that's my plug for decimal degrees. And some of you have probably been bored by this before. Anyway, there are more coordinate examples available from this document, linked to below. The next three, for the sake of time, the next three modeling concept areas, I'm only going to show you the GCRO graphic model, hoping to save some time for questions. So projection, BIBFRAME has both projection class and property. Much like the concept areas above, the Marc to BIBFRAME converter takes the projection statement from the Marc record and converts it to an RDF label. What we've attempted to do here is to create projection subclasses based on the Marc projection code lists that we're used to. We've done this in a hierarchical fashion so that one can search by types of projections, cylindrical, conical, etc. We have tweaked these somewhat from the original Marc codes as we came across some newer projections that we wanted to include and found some to be inaccurately represented. An addition we made to the structure of the projections in the GCRO ontology file was to assign a projection preservation property to each projection, so that, for example, if you're looking for an equal area map, you'd be able to find those across projection types. And we used Wikipedia data for adding these preservation properties to our ontology. And you can see that association under the GCRO project preservation property at the top there. And while what we have here does very much mimic what was already possible in Marc with a few structural changes, what we'd really like to do for projection is to begin to use external sources for projection data rather than maintaining a list ourselves. We began modeling for reuse of EPSG codes and spatial reference systems data, which contains much more data about the variety of the projections themselves. And we hope to have a modeled example included in the final projection modeling documentation before the end of this project that would show how one might do that. And this is especially important for digital geospatial data. And there are some projection examples linked to at the bottom of the slide as well. Types of cartographic resources. Here we've done something radical and maybe ill-advised and taken and reorganized some terms from the LC genre form list and turned them into BF cartography subclasses. And while we didn't want to change too much of the existing genre form structure, we found that there is definitely room for more types of cartographic resources, particularly in the digital realm. And this is not showing all of the subclasses, but this graphic doesn't show all the subclasses. But here I've highlighted how we've added and expanded out the digital cartographic resources subclasses to include a few newer and more expressive types of cartographic data that are not well expressed by current terms. So something like scanned cartographic resources, static digital cartographic resources, interactive digital cartographic resources, something we might want to consider as we're thinking about typing cartography sources. I have to admit, I'm not as sold on this model as I am with some of the others that were presented, but for the purposes of this project, we decided to experiment with doing some more direct linking to the type of object as a subclass of cartography. And we'll see how that turns out. And then finally, the final concept that I kind of wanted to go over today was prime meridians. And we initially began to create a GCRO property for prime meridians. However, we were, again, thrilled to learn of another new forthcoming RDA unconstrained property has prime meridian, and we're happy to incorporate that into the GCRO recommendations. One thing to note here is that even though there are no GCRO classes or properties used in this model, the group is recommending that the RDAU property be used with an actual resource rather than a text literal, usually a place name. In the example above, by associating a prime meridian with an actual location, one can leverage other data that might be associated with that location. So, for example, if we were to say this prime meridian, we had the URI for the Royal Observatory, you could then leverage the longitude data that comes along with that object. This typically you see applied more with antiquarian materials with non-Greenwich meridians. Prime or central meridians also becomes an important data point for digital geospatial data sets, but would likely be modeled somewhere within the projection concept area. The way we've modeled here is more of what you would see as applied to a paper map that you might come across in your cataloging. So I've showed some models and I've showed some RDF. Coming back a little bit out of the weeds, a resource I did want to highlight that I hope might be helpful for those in the audience who might want to take a closer look at how GCRO is structured is BiblioPortal. This BiblioPortal is an offshoot of the BioPortal project. It's a relatively new tool that serves as a clearinghouse for library data ontologies. Here you can search, browse, share, download existing library ontologies. GCRO has been added to BiblioPortal, and I reference it here as a good tool not only for discovery of library-based ontologies, but also because it renders the OWL ontology file in a more human-friendly way. If you don't want to parse the OWL file yourself, I would recommend coming here to take a closer look at the overall GCRO structure. But also by browsing to specific classes or properties, you can see the fuller ontology development work that went into GCRO, including any definitions, relationships, and labels for each property and class. The good news is that there's still lots of work to do. So just due to capacity and the learning curve, there was a lot that our group could not get to in the time frame that we set out. We didn't do much modeling around parts of maps. It would be really interesting to expand out modeling for inset maps, ancillary maps, index maps, these types of things. Data situation, we did not attempt to represent, although I hear there might be something in the works around data situation in the cartographic community. Map features would be really interesting to model in some way. We heard from geohumanities, people who are interested in kind of leveraging those aspects of paper maps. Places, we did not tackle places. It's a large concept that I think is a broader community discussion. And also there's expert communities building gazetteers and linked data ways that maybe we want to rely on as a community. And then we didn't get as deep into the geospatial metadata as I was hoping to get into things around recording entity and attribute values. I think it'd be really interesting to get in depth in some of the, especially the data dictionary type things around geospatial data. I think that could open up a lot of discovery. So VitroLib, very quickly, as I see I'm running out of time. VitroLib is, so all right, so now we have, we have our ontology recommendations. What do we intend to do with it? VitroLib is a web-based linked data management tool being developed at Cornell. It was derived from the Vitro code base, and it can be used to create and manage ontologies as well as to create and edit linked data, instance data. At Harvard, we're running a local instance of VitroLib that is being customized to support cartographic and geospatial resource description. What you're seeing here displayed is some data from the Linked Data for Libraries Labs sister project of the Cartographic Materials Extension project. Here at Harvard, we worked to convert a set of 8,800 Harvard Geospatial Library metadata records and 5,100 Stanford Earthworks geospatial metadata records to the target BIBFRAME plus GCRO linked open data ontology. We reconciled agents, keywords, places of publication, placed keywords to linked data entity URIs, and converted the data sets and loaded them into this VitroLib instance. We also intend to use this instance of VitroLib to do some test cataloging for the cartographic resources model. Here you'll see the VitroLib interface with that's been customized to handle some of the GCRO properties. Here we've grouped together properties that a map cataloger might want to begin with, to work with when they're working with a new work. So for instance, if you were to click on the plus next to the relief property, because VitroLib is ontology based, it recognizes all the relief subclasses and allows you to select from that list and assert it to an existing work within VitroLib. VitroLib also allows for external entity lookup, so it doesn't, the data points don't necessarily have to live in the ontology. We can do live lookups. And for the Harvard instance, we'll be able to look up URIs for geonames, id.loc.gov, as well as ISNI agent entities. So we're still in the process of customizing this user interface to support cartographic data. And once done, we'll begin some test cataloging. It's the Harvard VitroLib is not currently publicly available. However, we hope to have this open by the end of the project, and we're exploring that right now. You can also see the RDF output in VitroLib. So as you're adding resources, you can view how, you can see here how all the different ontology properties are used to describe this resource. So upcoming work, we'll be doing some production test cataloging in VitroLib. We'll be building, and I don't expect we'll do a lot. We may only do a couple dozen, materials. We're also developing an application profile for the project using Shackle. Shackle is a W3C specification for validating graph-based data. I'm still in the process of learning Shackle, but what it ends up being is a machine actionable way of documenting what ontologies we're using for the project and how they're being used. And the intention is to make the ontology decisions in this project transferable and reusable across systems, and the Shackle profile will enable that. We'll have full documentation, including the OWL file, expanded RDF examples with side-by-side comparisons, more background and reasoning around the decisions that we've made, and finally a write-up of the project as well. But really, one of the most important questions remains is what is next? As this project is scheduled to end June 30th, is there anything to take away from this project that could be incorporated into existing ontologies? Is there a path for portions of this to be included in BibFrame or RDA or other ontologies? Is there a need for an ongoing group to take on the management or maintenance of these types of questions for the cartographic and geospatial resources community? And to that extent, You can provide feedback on the modeling decisions and any ideas for community management via the project's GitHub's issue page. The link is here. Or you can feel free to contact me directly. But this really, really excited to get some feedback and engage more with directions this community could take around modeling options for cartographic materials. Here's some related links and resources for the LD4P projects, and as well some links and resources for some of the other resources that I mentioned during this talk. But I did want to give people a chance to ask questions. So thank you for allowing me to present this project to you, and I'll turn it over to Matt.
Thanks, Mark. That was a lot of really great information. I encourage all of you to submit any additional questions and comments in the question box. One question that's come in, you kind of answered it at the end, but with the grant ending in June, how do you see the project moving forward, or if the LD4PCM group might just split into different things, people working on different aspects of that individually more?
Yeah, I see a couple of avenues possibly opening up. It's possible that the McGirt community might, I could see the McGirt community maybe taking on some of the leadership in this area. But also I think there's opportunities perhaps within PCC to push forward some of this. And I can't speak too much. There is a follow-on grant that's currently being considered by Mellon that would include more PCC participation in developing best practices. So I think that could be a path forward, and I'm hopeful of that. There isn't anything specifically in the next grant around. It's not named that we'll be doing something more for cartographic materials, but it doesn't close the door on that work either.
Got one more question that just came in. Wondering why you went with RDF type instead of RDA form of work.
That is a good question. I don't know. I can't answer that for you. I think it was mainly based on inheriting the approach that Biblioteca was taking to typing resources. So I think that's what happened with that model, is we ended up mirroring how Biblioteca was approaching it. But I will look at that. Thank you.
Great. Well, that looks like it's the questions that have come in. I'm just gonna. So I'm glad you all could all be with us today. You'll soon receive a short online evaluation form. Please take a few minutes to respond to the questions. Your comments are very valuable and help the ALCTS Continuing Education Committee plan future events. Thanks to Mary Aycock and Catherine Balick of the ALCTS Continuing Education Committee, and to Jazlee Cooley of the ALCTS Office for Technical Support. The support they provide makes it possible for us to present these webinars smoothly. So this was the final webinar of our 6-part From Marc to BibFrame series. Our next webinar, Introduction to R for Libraries, is 3 parts long and will be on May 9th, 23rd, and 30th. We also offer web courses, which are 4 to 6 weeks long, and e-forums, which are 2-day email discussions. You'll find more information on the ALCTS website. We hope you'll participate in other ALCTS continuing education offerings again in the future. This concludes our session. Thank you for joining us.